This is a probability lesson, and in this lesson, we're going to talk about using probability to make predictions in situations. All right, there's a probability scale, and all probabilities will fall within this range of 0 to 1 as a decimal, or from 0 to 100 as a percent. So our scale starts out from 0 to 1, or from 0 to 100%, and in between. And so in the middle is 0.5 or 50%, and that is where it is equally likely for things to happen. The best example of that is flipping a quarter. You can land on heads or you can land on tails. The closer it is to 1, the more likely it's going to happen. The closer it is to 0, the less likely it's going to happen. All right, here's an example. Given a six-sided number cube, determine the following probabilities and state how likely they are to occur. All right, so if we have the probability of 1, the probability of getting an even, or the probability of getting not a 1. Okay, so the probability of getting a 1. Remember, on a number cube, a six-sided number cube, you're just got the 1 through 6. So there's 6 possibilities, and there's only one 1. So we would have 1 out of 6, and if we divided that, we would get 0.167 about, because I rounded it. So if we go up here and look at our probability scale, 0.167 is way up here on by the 0.25. So it is less likely to occur, or very not likely to occur. Does it? Yes, but that's just what probability means. It means it's less likely to occur. All right, the probability of getting an even. Remember, even numbers are the numbers that are divisible by 2, and so that would be 3 out of 6, and if we divide that or reduce it, we get 1/2, which is 0.5, and so it's equally likely. If we roll, we're equally likely to get an even, as we are an odd. The probability of getting not a 1, well, if there's 6 chances and only one of them is a 1, there are 5 out of 6 chances. So our probability would be 0.83, and I don't know if my little clicker will work. Nope. But 0.83 is way over there closer to the 1, and so this one is more likely to occur. The following chart shows the rain chances for the week. Predict how likely it is to rain on each day. All right, so we have our chart here telling us our percents. So remember, your scale, a decimal is just a number. The decimal time, a percent is just a decimal times 100. So they're the same. 0 is 0%. 0.25 is 25%. And so we can use our scale for either the decimal or the percent. All right, so Monday is 22%. Well, if you place that on your scale here, it's down here, so it is less likely to occur. Tuesday at 87%, that's way down here, so it's definitely more likely to occur. I wouldn't recommend planning outdoor activities on that day. Wednesday, 100%, that says it's certain to rain. Thursday, 14%, 14% is way over here, so it's less likely. 55, okay, 55 is one of those odd ones because it's right after the equally likely. So I'm going to put that it's closer to equally likely or more likely, but you know, it's right there and it's closest to that equally likely. It'll either rain or it won't. And then Saturday with 10% and Sunday with 10% would be less likely chances. Okay, that's our rain chances and how you use probability to make predictions. Given the following survey, determine which statement is true. A librarian asked 90 students which type of books they liked, and she got the following data: fantasy books, drama books, comedy books, and mangas. So, in her 90 students, 10 liked fantasy, 25 drama, 15 comedy, and 40 manga. Manga? I'm not sure how you say it, but I know my kids like this one. All right, so what's true? And we have these choices. So let me read the choices to you. More than half of the students chose manga. Answer choice B, a student is equally likely to choose drama or fantasy. C, a student is twice as likely to choose manga as drama. Or D, a student is more likely to choose manga and fantasy. Okay, most of my students, when they see something like that, they don't even want to think about it. Okay, use your data to help you. And then make notes on your answer choices, because that does make a big difference. Let me show you what I mean. All right, so let's look at answer choice A. More than half of the students chose manga. All right, if I go up here and look, I have 90 students. So half of 90 is actually 45. So more than 45, I got rid of half the students. So more than 45 have to choose manga. So I go over here to my manga and only 40 chose it. So 40 is definitely not more than 45. So that answer choice is gone. I have proven it wrong. All right, answer choice B. A student is equal likely to choose drama or fantasy. All right, equally likely means they are the exact numbers or they're very close to being the exact numbers. And so let's go look at how much drama is. Well, drama is 25. And I'm going to move over here. Hopefully I'm in the frame, but if not, I'm sorry. All right, so drama is 25. And then fantasy, when we look over at fantasy, it's 10. Are those the same numbers? No, they are not equal. So it's not equally likely. So I would throw that answer choice out. All right, a student is twice as likely to choose manga. Twice as likely means doubled, times 2. So let's look. Manga is 40 and drama is 25. Well, 25 times 2 is 50, not 40. So again, that answer choice is wrong. Because I've done all the work, I know those are all wrong. I'm going to check myself and just make sure I didn't make a mistake. A student is more likely to choose manga and fantasy as compared to drama and comedy. All right, that and there means you're going to combine them. So manga and fantasy would be 50 students. And then drama and comedy is 40 students. So there are more students choosing the manga and fantasy options. So that is true. That's correct. So that makes that problem a lot easier when you're just using your table to help you make the predictions. All right, a bag contains colored candies. 5 are blue, 7 are green, and 8 are red. What is the probability of selecting a green, replacing it, then a red? And is this event likely? Okay, remember when you're dealing with compound events, there are 3 steps. Calculate the probability of your first event, calculate the probability of your second event, and then multiply your fractions. That's the 3 steps. So our probability of selecting a green, well, we have to figure out how many there are. So a green is 7 out of 20. Then we need to figure out what is our probability of selecting a red. Now, what we need to know on the red is, did that green go back in the bag? And it did, because it says we replaced it. So we replaced the green. So then there are 8 out of 20 reds. 8 out of 20 reduces to be 2/5. And so when we multiply our fractions, we get 7 out of 20 times 2/5, which is 14 out of 100. And you can make that a decimal or you can make it a percent. But 14 out of 100 is very low probability, so it is unlikely to happen. Some things to remember. All probabilities will fall between 0 and 1 as a decimal. Convert that to a percent, it would be from 0 to 100. The closer to 0, the event is less likely to occur. The closer to 1, the event is more likely to occur. There are two types of probability, theoretical probability, and you divide what you're looking for by your total possible outcomes. Then there's experimental probability, and you divide what you're looking for based by your total trials, how many times you perform the experiment. And then when you have dependent events, the denominator of the second event only will change. So, as always, thanks for watching. Remember, you can email me at bethemath@gmail.com.